Okay, so hopefully everybody copied the chart down into their notebook. Normally in class, I would give you 5 strips of DNA. So imagine that all your DNA in your cells is millions of letters, those A's, T's, C's, and G's. We are only going to look at one gene. So the scenario that we read yesterday said that we're looking at a gene that all vertebrates have in common. So you can think of a gene as kind of like a word. So the letters in the alphabet make up lots of words, and the words have meaning. So your DNA is made up of those A's, T's, C's, and G's, and they go together to make genes, like the words, and the genes tell your body what to do. Okay, so here are the 5 strips that we would have used. The trout, the dog, the whale, the horse, and the iguana. And those are the same animals that you have on your chart. Now in class, I would have had you cut those into 5 separate strips, and we would have compared them. So take a look. I have the fish and the dog together by themselves above that line. So I am going to look, these letters right here in this row for each of those animals make up their gene. So we are going to fill in our chart by looking at the number of differences between them. So what I do is I look, okay, in the first one, they're both T's, so they're the same. If I look at the second one, I have a C and a G, so that's a difference. That's 1. The next one is the same. They're both G's. The next one's both A's. Now we have a G and a C again, right? So that's a second difference. The A's are the same. Look over here. We have a difference. T and C, that's 3. Another T and C, that's 4 differences. The G's are the same. The C and the A are different. So that means that a trout and a dog in this gene have 5 differences between them. So if you go back and look at your chart that you did, see how I had the 5 here? That's because between the fish and the dog, there are 5 differences. Okay? So guess what we're going to look at next? We're going to look at the fish and the whale. So we're going to go and we're going to look at those. So take a second and see if you can count those up by yourself. Pause the video and count how many differences the trout and the whale have. Okay. You should have seen 1, 2, 3, 4. Okay. So in this column, we are going to put a 4. Okay. Now we are going to look at the fish and the horse, which is here. Okay. So take a second, unpause when you're ready, and see how many differences you can find. Okay. So when you did this one, you should have seen 4 again. 1, 2, 3, and 4 at the end. So in my chart, I'm going to go back and I'm going to put another 4. Okay, let's try the fish and the reptile. Okay, find your differences. You should have found 4 again. 1, 2, 3, and 4 right here. So in my chart, I'm going to go back. I'm going to write in number 4. Okay, so see how we've X'd out this box? Because that box has us comparing the dog and the dog. Obviously, they're the same. So now we're going to compare the dog and the whale. So if I go down to my slide, how many differences do you see? You should only see 1. The only difference, these are all the same, except for right here, the C and the T. The rest of them are all the same. So in my chart, I'm going to add a 1. Okay. Now we're going to look at the dog and the horse, which is right here. See if you can find them. Okay. Again, you should only be seeing one difference. That's between the C and the T. Right here. All the other letters are the same. So up in my chart, I'm going to go back, and in your notebook, you're going to add that there was one difference between the dog and the horse. Okay, let's do the dog and the iguana, the reptile. So if I come down and I look at these strips, how many differences do I see? Okay, you should have come up with 1, 2, and 3 at the end. So on your chart, you are going to write the number 3. Okay, third row, I have the whale. I do not need to compare the whale and the dog because I already did that when I did this, the whale and the dog. So I don't have to compare the whale to itself. So all that is left to compare with the whale is the horse and the reptile. So let's look at the horse. I believe that's this one. No, this one. No? What am I looking at? The whale and the horse, right? I have that. I skipped that one. Here it is. Okay, I'm sorry. The whale and the horse. How many do we see? Are you saying 0? You should be saying 0. They're exactly the same. Now remember what we read about when we learned about whales, that they think that whales evolved from hooved animals. Well, what's a horse? Hooved animal. So it makes sense that their DNA is a lot more similar. So up in my chart, I am going to put a 0. Okay, let's take a look at the whale and the reptile. Here we go. How many differences do we see here? Are you saying 2? I have the first one is different right here. And then I can go all the way across until I get to the last one. The A and C is different. So on my chart, I'm going to put a 2. Okay. I only have one more comparison to make. I've made these comparisons already. I just need to compare my horse and the iguana, the horse and the reptile. So I'm going to go back and I'm going to look at these. See how many differences that you can find. Do you see 2? You have one difference here. And again, these are all the same until I get to the end, and that's a difference. So in my chart, I'm going to add a 2. So your completed chart for part A should look like that. Double check, pause the video, double check your numbers if you need to, make sure you have everything correct. Now what you're going to have to do is do that once by yourself with some different DNA strips. So for part B, we are going to look to see, does every species within a class display every common characteristic of that class? You remember when I mentioned we did the vertebrae activity where we read the letters from the Murray Jones was the platypus, and Phil, there's our little kiwi bird down here. We talked about the seahorses. There's the armadillo and the bat. So we're going to use a lot of those same animals that we've already learned about, and we are going to compare them to the horse, the dog, the whale, the fish, and the iguana. Okay, so what I need you to do today is to complete this chart. I want you to fill it in. This is the part B chart. It is number of differences between DNA sequences. And you know what? I'm actually going to have you say part B on here. Let's say part B. Number of the number of differences between these DNA sequences, okay? because I keep referring to it in the directions as part B. That way it makes sense to you. So you are going to have how many? 1, 2, 3, 4, 5, 6 columns and 1, 2, 3, 4, 5 rows. Again, you're just putting numbers in here. So you just need to leave enough space for that. And then there are no blanks because this time it's different. The animals on the top are different than the animals on the side. So you will have to fill in all of these squares. You're not shading or Xing anything out. So once you have your chart completed, in the classroom, in the stream, there are links, there are PDFs of the different samples of DNA. And I tried to line them up for you to make it as easy as possible. But you will find all of the different comparisons there. And all I want you to do for tomorrow is take a look at those comparisons and see if you can do it without my help and see if you can complete that chart. If you have questions or you're working and you're confused, send me an email and I will get back to you with an answer. Don't sit and be stressed about it. It's probably something very small that I can help you with. So we're going to go over it tomorrow, make sure you did it correctly, and then we'll talk about what those differences actually mean. So good luck, do your chart, look at your DNA samples, and see what answers you can come up with. And then we will talk about this again more tomorrow. Okay? Thanks, guys. Have a great day.